Hey everyone, and welcome back to another CTF Writeup video. In today's video, I'm going to be covering the web challenges as part of ångstrom CTF. Overall, pretty fun challenges, definitely more beginner focused, but they got a little bit difficult towards the end. I'm going to be going pretty fast through the walk-ups. I'm pretty much just going to talk about this is the exploit, this is how you get the flag. If you have any questions, feel free to leave it in the comments, message me on Discord, Twitter, email, anything. If you think there was an easier way to solve any of the challenges, please also leave that in the comments. If it's useful, I'll pin it to the top. And with that, let's get started. The first challenge is catch me if you can. It says somebody help and we're given a link. So if we go to the web page, we can see the flags kind of rotating in this little red box. We could try to decode it manually, or we can just go to view page source, scroll down, and we'll see the flag right here. So the next challenge is Celeste Speedrunning Association. We're given a web page. It says welcome to the speedrun records. Can you beat them? Play for a flag. And it sees the current record is 0 seconds. So somehow we have to beat 0 seconds. If we go to play, we can see all there is a button. And if we view page source, we can see it's a form. And one of the form elements is a timestamp with the start. So I think the idea is that we need to be able to submit this button faster than 0 seconds. Obviously, no matter how fast we click that submit button, that's not possible. But thankfully, we can just take this form out and change this value to whatever we want. And so we can submit a value in the future. And so then our record would be faster than 0 seconds. So that's what I did. I wrote a little Python script. We're making a post request to the submit endpoint, and all we had to do was pass that one data field. So there's start. If I grab this real quick, I'll paste it in here, and we'll just change this to the future. So instead of a 6 here, I'll put a 7 here, and then we'll print it out. And there we go. You win the flag. ACTF, wait until farewell speedrun. The next challenge is short circuit, and it just says bzz and gives us a web page. So here we have a login page. If we view the page source, view source, there's a script, and there's a function called swap that's defined, a function called chunk defined, and a function called check defined. And if we go to the form element in HTML, we can see that when we click the submit button, it's going to call check. If we go to the check function, we can see it's going to check if the username has value admin, and then it's going to do this weird if swap chunk password is equal to this, then we win. And if we look at the value it's supposed to be, we can see there's this ACTF in here, there's an open bracket, close bracket, client side sucks, so this is probably the flag, it's just like mutilated somehow. And we can see that it's being passed to this chunk and swap function. So what I did for this is I wanted to see how the chunk function worked without actually having to read too much because we're lazy. And so I did A is equal to that value we just grabbed. Oops. So this is the flag it's being compared against. So if we do chunk A30, which is what the source code was doing, we can see it splits it, and it splits it pretty well. We can see it starts with an ACTF here, and it ends with the bracket here. It's just kind of mutated or swapped. And so I was hoping that swap would just kind of reverse the operations after you call it a couple of times. So I did swap, chunk, what was it, A30. And we can see this is not quite correct. It doesn't start with ACTF. So then I called swap on it again, and we can see ACTF, blah, 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 and it ends with a bracket. So either this is correct or the middle two things need to be swapped out. But I decided to give this one a try. So I did join, and I joined with a empty string. And so this is our answer. And it's easy to validate because we have this little function here. So we do admin, we type in that password, log in, and it takes us to the win route up here. So we know we got it correct. So fun little challenge. The next challenge is directory, and we're given a web link. So if we go to the page, it's just a whole bunch of page links that say page and then some number, and I think it goes all the way to 5,000. And so instead of verifying each one of these, if you click on a couple, it says your flag is in another file. We go down here, your flag is in another file, so presumably one of these links either has the flag or has instructions for us. So instead of clicking through them, you can use wget to just download all of the links. So that's what I did. You just do wget recursive, no parent, so don't go up when you're recursively downloading everything, and you give it the URL. So if we run this, this is just going to download every single one of those links. It definitely takes a little bit of time. I ended up downloading to about 3,000. So while this was happening, you can then run grep r actf. ACTF, and see this is grep, so look for the string ACTF recursively in this current directory. You do a little period, and we can see that in the file 3054, it has the flag. And just to verify, we can go to 3054, and it should be this one. And there we go. ACTF, you found me, and then a little hash. The next challenge is Celeste Tunneling Association. It says welcome to the tunnels, and we also get the source. So if we go to the URL, it says, welcome to the tunnel, watch your step. If we view the page source, there isn't too much, there's just one route, and basically it's going to validate if it's a HTTP request, it's going to look at the headers, then it's going to send back a response, and then it's going to parse out the host header, and it's going to check if the host header is equal to the secret site, and if it is, it'll send back the flag. And the secret site, it needs to be equal, or the host header needs to be equal to flag.local. So for this challenge, all we had to do was send a request with that host header and we win. So nice and simple. We do a get request to that URL, we set the host header, and we print the text. So Python 3 solve, and there's the flag. The next challenge is hallmark. It says send your loved ones a hallmark card and maybe send one to the admin, and we're given source code. So this has a admin bot, which means that we're probably going to be doing a XSS or a CSRF. If we look at the actual page, hallmark greeting cards, we can choose a card type. So we can send flowers or cake or heart. And if we send this, we just get back the image. And if we send custom text, we can try doing a XSS, script alert, send the card, and we just get the echoed text as a response. We can see View Page Source is not rendering this XSS, and that's because if we go over to network, we look at the card, let me do a full refresh. If we look at the content type, it's text plain right here. So this wouldn't be rendered as a XSS. So that's interesting. If we look at the page source, I'm going to go pretty fast over this, just talk about the things that are interesting. First off, there's this body parser, extended equals true. So that means we can use arrays and stuff in the body, which is useful. We can see the flag is loaded in the process, so we're probably not going to be looking for shell. We're somehow going to exploit the app. We already knew that because there was an admin URL, so it's either going to be an XSS or a CSRF or a cross-site leak or something. We can get cards, and this is where that issue we were running into with that XSS. It's going to set the content type equal to the type on this card object. So we don't know how we create these card objects, but somehow on here there's going to be a content type. So definitely interesting. We can create cards. So when we do a post, it'll get out the SVG and the content. It'll see what type it is. If it's a text, then we get to set the card content, but it gets the type of text plain, which is what we saw on our XSS. Otherwise, if it is a known SVG, so it's one of these images that's up here, the heart, snowman, flower, cake, it'll set that to the content, and that'll redirect us to see the card. This wasn't shown in the web app, but there's another route for updating a card. And we can see it's going to grab rec body, it's going to take the ID type, SVG, and content, make sure that this card exists, so one for that ID. And then this is the tricky logic, and here's where the bug is. If the type is equal to image SVG, it'll keep that type. Or if type is equal, and then again, it's going to check if type is equal to image SVG, it'll return that image in the image object, the image object, otherwise it'll return the content. The bug here is a little bit subtle. It seems like this shouldn't be possible to break. Ideally, what we want to have happen is you can actually inject an XSS into an SVG file. SVG files, they're still written in that, the bracket sort of markdown syntax, kind of like HTML. And you're actually able to put script tags in these SVGs. But the way the code is written, if you kind of just go through it yourself, you can see it doesn't really seem possible to both specify a content type of image SVG and also provide your own content. But if we line these up, the bug becomes a little bit more apparent. We can see here it's using this double equal, and here it's using this triple equal. And that's super interesting. And if we take a look, I guess you just kind of have to know this trick, but if we say A is equal to A, obviously that's true. But what's also crazy is this is also true, but this is not true. So we can pass in a array, and it'll match the first element with this double equals. I think this, if we do, it's being silly. If we do A is equal to A1, I think this is false, yeah. It can only be an array, it can only have one element, and it'll match the first one. And so that's why that body parser thing, extended equals true, was necessary, so that we can pass arrays in the body. So, taking a step back, what we're going to be doing there's one other thing we need to talk about. There's this flag route, and so it's going to check the cookies, it's going to check if the cookie secret is equal to secret, and if so, it'll send the flag. And so only the admin bot can hit this route. And so I think this kind of puts all the pieces together. Cool. So this is the base URL. This is the URL of the actual challenge. This is an ID of a card I just made. We just need one ID so that we can update it. And this is that payload I was talking about. So we can embed XSSs within an SVG. And so we can see here, this is what an SVG looks like. We can see here is a script tag, and it says let C is equal to fetch the flag. Once we fetch the flag, convert it into text, and then take that text, I call it data, and set the top level window location equal to webhook.site, and I set it as a URL parameter over here. And so we want the admin to execute this. So we're going to make a request to update the card on the website. So base card, we're making a put request. We're going to say the ID is equal to ID. And here's that one tricky thing is we're going to say type is equal to an array with the first element equal to image svg xml. Then we're going to set svg equals to empty. We just need it. And then we're going to set content equal to this payload. And we make sure to URL encode it. Then we're going to, I just print out the response. I make sure it's a 200, blah, blah, blah. And I don't think we need this. This was just for me to verify that everything was working. Once we have this, we just send it to the admin. So I'm going to do Python 3, solve.py. It says OK. So we know that this ID is a good ID. And we can actually open this in here and see what it looks like. It's going to be mad, but let's view page source. Oh, it went too fast. Let me go back to, let's do view page source. It did the redirect too fast. So this is the response we get when we go to that card ID, and we can see it has that XSS payload, and just due to syntax highlighting, you can kind of guess that it's going to be executed. And so when we don't view page source, it automatically executes, and it'll redirect us to webhook.site, and you can see the C is equal, you can't view this mad face. But obviously if we send this to a admin, the admin can see it, and so we should just get the flag. So let's load this, copy that out. It was webhook.site. Let's see, it's going to go to, oh yeah, we're already getting responses, 1CD. Let me just make sure I'm using the same one, 1CD, cool. So let's go to the admin bot. We'll send that here. I am not a robot. And where's the webhook? It's that one. I'm going to click submit. I'm going to go to the webhook site, and here it is. The admin has received your card. So fun little XSS. The next challenge is broken login. This was my favorite challenge as part of the CTF. It says talk about a garbage website. I don't think anyone's been able to log in. Make sure to let the admin know, and we're given source code for both the web app and the admin bot code. If we look at the web app, it just says number of failed logins. We're given a username and password, so a little login form. We do submit. It just says wrong username or password. You can try SQL injection, but it's not that. If we go back to the page, not now, and look at the bot code, the bot code's pretty interesting. It's going to go to that page, and it's going to set the username equal to admin and the password equal to the flag. So kind of a different challenge. So if we think about how we're going to exfiltrate that, the bot code's going to go to that page, set the username and password field, and then hit submit. And somehow we have to extract the password field. So either we would need maybe an XSS in the page that's continuously reading, and we're able to hijack the submit button, for example, and steal that password. There's another attack, the attack I ended up doing. You can do a dangling markup injection attack. I won't go too much into it, but postcards from a post XSS world, I think is the name of the article. Yeah. This is a awesome article all the way from 2011, so it's an old article, but it talks about how to do all these dangling markup injection attacks. And basically the idea is if you have a form, and let's say you have some input, and a submit. This is not valid HTML, obviously. If you're able to inject content up here, sometimes it's possible to inject a new form tag, action to evil.com. And then you put like a quote here that'll eat up all the content until here. So it looks a little bit weird and it's invalid HTML, but basically what happens is if you're able to inject this form element above, it'll just continuously eat stuff until this, and it'll clobber the second form so that any content in here will be sent to evil.com instead of the original target. There's a bunch of these dangling markup injection attacks. But that's the one I ended up using. You could also look into doing like a base href attack. So this will set the new base for where everything's going. Actually, I don't know if we could do a base href here. Oh, we could. Yeah. So you can specify, right now this is just showing only the path. It's no, it's not like the, whatever the challenge.com was URL. And so because of that, if you were to use a base href, you can kind of set what the host is, and you can say the actual, like anytime it's only given a path like this, send all the requests to evil.com instead. So that's another attack. And there's probably more markup injection attacks we could do. So I knew kind of what I wanted to do, or I had a guess for what I wanted to do. I just needed to figure out how to inject that content. So now we can look at the actual app server. So in the app server, there's this giant index page. We can see there's a %s and a template thing here, which is pretty interesting. And there's two routes. There's this post request, which will, I'm doing the easy one first. Well, it'll update this fails +1 and make a response saying wrong username or password. So we can see we're not actually supposed to log in. There's no content on the other side. Then there's this get request. We didn't see this on the initial web page, but there's a message parameter we're able to pass. And as long as it's under 25 characters, the web server will do an escaping on it. So, it'll remove all the XSSs and then pass it to this render template string function. So this is where our custom message will go. And we can see, thankfully, this custom message is above the form. So that's good. And yeah, we're not able just to do a raw, XSS because of this escape function. So because of that, we can't just pass in like, form or whatever into here. I mean, we can try. So if we go over to the source code or login, let's do view page source. And it was equal to message is equal to ABC. Oops. Let's just make sure it's working first. We can see ABC is right here. But if I was to try and inject form, we can see it's going to be escaped. We're going to get the less than and greater thans. Like, it's pretty much impossible. But the other bug in here is this is vulnerable to template injection. We can see it's using the render template string function, and it's going to pass our custom message to that. And if we take a look, we can see that we get angle bracket, or we get these brackets here that we need for template injection. Okay, so we have a couple of things. First off, we kind of know that we want to do some sort of dangling markup injection attack so that we can exfiltrate the password. When the admin bot types it in, we're able to do a template injection attack, but it has to be less than 25 characters. If we could do any length of template injection, we would most likely be able to just get shell on this box and do whatever we want. But I'm pretty sure the challenge authors, they specifically picked 25 because they know it's not really possible to get real command injection, template injection sort of attack in under 25 characters. And we also have that escaping, which makes things just a little bit more difficult since we're kind of limited on the character set we can use. Eventually, it took maybe quite a few hours to kind of figure it out, but the real insight in my mind for solving this challenge was realizing that you can add another parameter and just reference that parameter. So what if I was to do a is equal to abc and message is equal to request.args.a? I think this is right. So the XSS filtering or escaping only happens on this parameter, but anything in here, it doesn't matter. And the length restriction only happens on this one. So we can put whatever content we want here, whatever length we want in here, and it won't be filtered. We can just do whatever we want. We don't get template injection in this. This is just being reflected right here. But if we add the safe parameter, safe, we're now able to inject whatever tags we want here. So I'm going to inject a p tag, and we can see we got p high. So cool. So we have a full XSS at this point, and we can do our dangling injection attack. Like I said, we're going to do form. We're going to do action is equal to, let's grab the webhook site URL. We want this. We'll copy that out. So our action is going to be equal to that URL. So when the admin bot hits submit, it'll go to that website, and then we want to kind of clobber the rest of that form so that it uses our form instead of the real form. So I'm just going to do b is equal to open quote, and I won't close it. So when we look at the page source for this, so we can see form action, this is our evil action, and then b is equal to open quote, and thankfully Chrome has syntax highlighting, so we can see b is going to be equal to all of this all the way to here. This is a little bit strange. Thankfully Chrome just kind of ignores it for us. But then it's method equals post. So this is now the new form tag, all of this. And we have an action and a method, and then this garbage field B. Cool. So when the admin bot goes to this page, they're going to submit, and we should be able to just steal the username and password. So let's copy this URL. Let's give it to the admin bot. URL submit, post, submit. And we get a post request, and there's the password. Admin still can't log in. So very cool challenge. The last challenge is filestore. This challenge took us the better part of a day to solve. It was definitely an involved challenge. So if we go to the URL, we're given both source code and the URL. The source code is actually a zip file or something, and it has all the contents, including a Docker file, which was it ended up being pretty necessary to solve the challenge. If we go to the website, it gives us the source code. There's two things we can do. We can either do a post request or anything else, which is probably just a get request. If we look at the get request first, it says if set this f parameter, it'll include that file. Which is crazy. There's no filtering or anything. So right here we have a LFI. And so, I mean, we can just play with it. We can go f is equal to, ignore all that other stuff, etc password. And we can, something's wrong. There we go. I just need one more directory. We can see, you know, we get back the contents. So we can view files on disk, and we also include them. So if there's any PHP in here, it would be executed. So that's awesome. The other route is this file upload route. And so if we make a post request, as long as the file is less than 1,000, it'll generate a unique ID, and it'll move the file from the temporary directory, wherever it's being temporarily saved, to this uploads folder. And it'll take the hash of the file name we provide, include the I, and also the original file name. Cool, so if we combine these two bugs, this looks perfect. It looks like we could just upload a file and then request it using this include statement, and we'll have shell on the box already. The trickiness is this this unique ID. Unique IDs, they're not cryptographically random or anything, but they still use microseconds, and it generates a lot of them. I mean, you can try to do the timing attack and find a before and after, and maybe you'll be able to guess this file. But we were having a lot of trouble with it. Maybe it's possible, maybe it's not. I think we had to leave our script running for like 2.5 hours to run through all of them, and the server was just super slow. I think everyone was hammering it doing this, and so we just couldn't get on the box that way. Maybe it's possible, maybe it's not. I just didn't trust it. So what we ended up doing was a completely different attack to initially get on the box, and that attack that we did was this one. So this is LFI to RCE via PHP session upload progress. So what happens is when PHP is doing uploads, file uploads, it's possible that it might take multiple chunks or something to do that upload, and it'll create a session file for you. So taking another step back, PHP, when you create sessions, it'll save that session onto disk with a file called sesh underscore and then that cookie name or that cookie value. And so if we could trick PHP into creating the session file and inject content into that session file, then we could request the session file with this include statement and execute arbitrary PHP. So the attack we ended up using to get onto the box didn't involve this move file stuff at all. We just relied on the fact that we were able to do file uploads. And then from there, we tried to create a session and then request that session file that had a PHP command in it. To do this attack, it is a race condition. So we had to kind of script it. This kind of shows what it looks like. So if you make a curl request with this cookie header, and then you look at the temporary directory, you can see nothing was created. If you create it with this header, cookie, and this data, PHP session upload, still nothing happens. But then if you do hcookie, the cookie, the file, and file, we can see at this point it finally creates a session file. And in this case, the session file will contain the string blah, blah, blah. But using this, we can put whatever we want to the session file, including a PHP backdoor. There's a couple differences. Thankfully, as part of this challenge, we're given the Docker file, which was huge, so that we could actually see where things were lined up on disk. In our case, when we did this, the session files actually went to the temp directory, not that other directory that they were talking about. And it was nice to just be able to validate that that file is actually being created because it is a race condition. So to actually get onto the box, this is the Python script we wrote to actually run the exploit. Cool. So we have to do this multi-threaded, and we just have to execute it fast, and every once in a while you get lucky, you request the session file while it still exists. So this is the function for creating that session file. So this is the payload I want to send onto disk. So PHP system The problem is that the session files are constantly being deleted after they're done with the upload. So you need to grab that session file, execute it, and then create a new backdoor that's more persistent. And so this is the script we use to create a new backdoor. So PHP system curl, this just little backdoor that was on some GIS somewhere. And we're going to upload that and send it to temp sjp.php. So that'll be our semi-permanent backdoor. We're actually going to move that backdoor in a second, but we want the script to execute, so it'll put a semi-permanent backdoor on this in that directory. This is the data we send. We're going to send PHP session upload progress with this payload. This is just from that article we saw. We're going to send the headers, so our PHP session is equal to sjp, and then we just send a garbage file. And so as we make this request, it should very quickly create that session file somewhere on disk, and then eventually it'll be deleted. In a different thread, what we're going to be doing is trying to request that session file that has that backdoor in it, and we want that to execute and create our semi-permanent backdoor. And so this thread will just constantly be requesting that file, and eventually we should get lucky. What this final thread is going to be doing is it's just going to be checking to see if we actually created that backdoor. And so it's going to request our more permanent backdoor, temp sjp.php, and it's going to send the command echo winner. And if we see winner in the response, we know that it worked, and we'll exit everything. And so we just import thread. Since Python 3, there's a better way to do this. I was just being lazy. We started a bunch of threads that all create that session file over and over and over, and then we have a thread to verify and execute that backdoor, and then one to check to see if the backdoor actually exists. And so if we run this, Python 3 solve.3.py, this is my third different idea, that's why there's 3 of them. Eventually we can see we're able to create a backdoor. So cool, so now we have a backdoor on this web server. And it was temp sjp.php. And we send it a command of command is equal to ls, let's say. Cool, now we have shell in the box, so that was step 1. The second part of the challenge was privilege escalation, and the Docker file pretty much told us that we're going to be doing a privs sort of exploit. If we go through this, there's a couple things that are interesting. First off, they're going to copy over a flag file, so there's a flag file in the Docker container, and the flag file is owned by admin. Cool. If we do a who am I, ls, we'll do who am I, we can see we are the CTF user. Cool, and we can also verify that the flag is on disk. We'll do ls root, and we can see there's this flag.txt. Actually, let's do lsla. La. Cool, so we can see, yep, it's only readable by admin and the admin group. There's actually 3 other interesting things. First off, these are very weird binaries. There's this list uploads binary and make abyss entry. And if we actually go back to the original source code, the original file server, they had this comment down here. It says this doesn't work, so I'm commenting it out, system list uploads. So very strange. So there's this list uploads. It's executable. Both are executable by anyone, but it's a setuid binary, so it's going to be executable as the admin group. And here's root 2. So interesting. So we have 2 setuid binaries. Whenever you have a setuid binary created as part of a challenge, you know you're probably going to be doing a privilege escalation related to that. And then there's also this abyss folder. So I'm going to skip a little bit of time. If you do this make abyss entry, what this is going to do is it's going to create a hidden folder in this abyss folder for you that only you get to use. And I think it's just a way to kind of hide your work. Otherwise, everyone's going to be working out of the temp directory. And we're just going to be clobbering each other. And it was also, once you know what the exploit is, if other people saw it, you would instantly know what to do. So all this is going to do is it's just going to create a hidden folder for you to put, a more permanent backdoor and a staging area for your next line of exploits. Then there's this list uploads binary. If we actually open this up in Ghidra, this is what it looks like. What's interesting is it's making the system call to list up all the uploads, but it's calling ls without the full path. And that's what the actual bug was. So if we could run this binary runs as admin. If we were able to set the path before calling this binary, we could have it use a different ls. And that's what the actual exploit was. There's one other thing that makes it a little bit tricky. I'm going to cover this before I move on to the solution. They actually delete a bunch of files. They delete chmod and chown, which just adds another little step of interestingness. But anyways, that was the Docker file. So we kind of know what we're going to do. We're going to create a folder in Abyss, a private little workspace. We're going to create a ls file that we will then use for exploitation. And that ls file will cat out flag.txt. Then we're going to run the list uploads folder. We're going to set the path such that it'll find our ls before the system ls, and it'll cat out the flag as the admin user. So this is the final stage of exploitation. First thing we're going to be doing is we're going to be creating that sneaky ls file. And so the contents of that new ls file are going to be bincat flag.txt. We have to make sure we have to do a full path on bincat, a issue I ran into that stopped me for a good 20 minutes, which I'll talk about in a second. In the Docker file, there was no chmod, so we had to find a way to execute the syscall chmod and not the binary chmod. Thankfully, PHP does the syscall chmod, so we just create a little PHP script to do chmod on our ls. We need ls to be executable, and so this step was necessary. Then we run that PHP script. So we're going to run our chmod script. So now ls is executable, and so now we're going to set the path equal to our Abyss folder, the current working directory to our Abyss folder, and then we'll call list uploads. So list uploads should then call our sneaky ls, and we should just skip flag. So let's execute all these different commands. So that creates a ls. Then this one should create that chmod file, the PHP one. Let's execute that PHP one. And then let's see where we currently are and make sure everything exists correctly. So let's do an ls la, and let's print out the entire directory. So we have a chmod.php, we have our ls binary, or backdoor, I guess, which has 777 permissions, so it is executable, and we should be are ready to grab the flag. So our final command will set the path and the current working directory, and then execute this list uploads command. And there we go. Everything came together. ACTF, watch your path. So pretty involved challenge, but definitely very fun. So all in all, a lot of fun web challenges. The first couple, I think this is a high school CTF, so it took a while to get going, but the last two were very difficult. And if there's any high school students that solved this, the last three, props. That's very impressive. But anyways, fun CTF, and I'll see you at the next one. Cheers.